Now, our orthogonal rotation is really cool, so to speak. Now, but I want to I want to examine this further. So I call this PCA 2. So I want to go into this and look at things a little more closely. Now, what I would like to do is I'd like to come into my PCA loadings, and I don't want all these small, like negative 0.04. The only thing I want to show on question 20 is this one, because this is the PCA loading that tells me the question 20 loaded on component number 1. So I don't want this garbage right here. I don't want 0.07. I don't want 0.14. So if you remember from the previous video, we can do the print psych. And we can do our of our PCA2. And we can set our cut. I'm going to set it a little bit higher here at 0.4 because our model really turned out pretty cool. So here's what I get. Now, what I like is when I look down through here, I don't want a lot of replication. So I'm looking at components 1, 2, and 3. And when I look down through here, the only thing that I have that loads on 2 components is question number 12. So I might want to come back over here and examine question number 12 and see what's going on with that. So question number 12, people try to tell you that R makes statistics easier to understand, but it doesn't. And I can see where that's kind of a vague question. It has loaded on 2 components. To be quite honest with you, I would probably consider eliminating that question if I really wanted to strengthen up the reliability analysis of the survey. But I'm not going to go with that. I'm going to just come in and I'm going to write these down. So factor 1, let's go with that. So that's under RC1. So it looks like, I'm going to write this down. So we have questions 20, 21, 3, 12, 4, 16, 1, and 5 that load on component 1. Now, what do those questions have in common? So I got to go back and I don't even think I'm going to use that, so I'm going to get rid of that. I got to go back and think about what these things actually have in common. So question 20, I can't sleep for the thought of eigenvectors. Okay. I wake up under my duvet thinking I'm trapped with a normal distribution. Okay. Question number 3, standard deviations. Starting to see a pattern. Number 12, that's the one I think is a little vague. I'd probably consider getting rid of that. This is talking about a Pearson correlation, number 4. 16 talks about central tendency. Notice that every one of these questions has terminology dealing with statistics. Statistical terminology. So guys, I'm going to call factor number 1 my statistics factor. Let's come back in and look at factor number 2. Factor number 2 over here deals with questions 9, 22, 23, 2, and 19. So let's see what those questions have in common. So question number 9 says my friends are better at statistics than me. 22 is my friends are better at R than me. 23, if I am good at statistics, people will think I'm a nerd. Okay. My friends, and number 19, everybody. So this is a kind of I'm going to call this a peer, a friend, if you will, a peer evaluation. How the subjects think about kind of peer perception. Let's go on through the next one because this turns out to be kind of the hardest part. Let's look at component number 3. So I'm going to write these down. So 6, 18, 13, 7, 14, 10, and 15. And again, we're with this question 12, even though it loaded above 0.4, we're going to have it on component 1. So component number 3 here, let's go over here and look at these questions and see if we can determine something that's common. Number 6, I have a little experience with computers. Number 18, R always crashes, so that's a computer. 13, computers. 7, computers. I think you see where we're headed here. 14, computers. And 10, computers. And 15, computers. Guys, I have no doubt that factor number 3 deals with computers. So I'm going to call that a fear of computers. So the only thing we're lacking now is the short one. So that's question 8, 17, and 11. So question 8, mathematics. Did I say 8, 17, 11? Equation, mathematics, 11, mathematics. So guys, that to me is the mathematics component. So these underlying constructs that we've kind of unraveled or we've detected, it looks like to me are fear of computers, fear of statistics, fear of mathematics, and a kind of a peer evaluation component. Okay. Now, what can we conclude once we've got this big old fancy schmancy these factors that notice that emerged so nicely and very mutually exclusive, if you will, on these components? I don't really know what we can conclude. Maybe maybe there's nothing going on. Maybe it failed to measure any sort of R anxiety, but did find some interesting stuff like fear of computers and fear of math and stuff like that. Or it could be very likely that the 4 constructs that we have tapped into here, again, fear of computers, fear of statistics, what people think of us, and so on and so forth, are truly constructs or subcomponents of the anxiety of using R. Well, guys, that's the one for bigger, better things. That's something that you guys will have to figure out. Okay. Now, think about what we got going on here. We've got the components turned out to be fear of math, fear of stats, fear of computers, and peer evaluation. Now, is it reasonable to think that these things may be correlated? Is it reasonable to think that fear of math is independent of fear of stats, that's independent of fear of computers? I would say there's some sort of interdependency going on here. Now, one assumption of orthogonal rotation is independence, or I should say uncorrelated components. And it looks to me that we can reasonably, qualitatively, if you will, say that there probably is a relationship between fear of math, fear of stats, fear of computers, and fear of evaluation, especially the first 3. I don't have a fear of math. I don't have a fear of stats. I don't have a fear of computers. Sometimes I care about what people think of me, but it just depends on who the people are. So I don't know. I think if you ask most people this question, you may reasonably conclude that there is some sort of relationship there. So we would want to examine this with the orthogonal. With an oblique rotation. So I'm going to call this oblique, and I'm going to run the principle. And really, all I want to do here is I want to run the same thing. And I tell you very honestly here, what you hope, just because. Okay, I forgot how to do this. Oblique. Like, is that it? Oh, Blemon. Yeah, okay. What I always hope is when I run these that I get the factor loadings that they're very, very similar to what I got from the orthogonal. Because orthogonal is just, it's a rotation that you see presented more often. It's something that's more understood, it seems to be. So that's kind of what I hope for here. Now, the first thing I notice is 0.96 is the same. That's encouraging. The next thing I want to look at is the component correlation. So we can see that component 4 and component 1 are highly correlated at 0.44. In fact, component 1 and component 36, component 3 are relatively highly correlated too at 0.36. Component 2 and component 4 are not highly correlated at negative 0.1. Doesn't matter. So this kind of raises the eyebrow and makes me think that the oblique rotation may give me different results than the other. So let me go back up. I didn't write down component 4 was what, 8, 17, and 11. So guys, all I did, I'm not doing anything fancy here. Only thing I did is just on a sheet of paper over here, I wrote for component 1, for example, that I have question 20, 21, 3, 12, and so on and so forth. I did that for all the factors, or all the components. Now, it's going to be easier for me to read here if I do the print psych. And I want to do, what did I call this? PCA oblique. And I want to keep my cut consistent at 0.4 and sort. That's kind of a handy tool to do that. Okay. Now, when I come back up here, I look at my component 1. I see 6 and 18 and 7 and 13 and 10 and 14 and 12. 12 actually loaded on component, on a different component, this one. And, so the oblique gave me a little difference in question 12. Question, 8, 11, 17 turned out to be the same. 20, 21, 3, 4, everything but question 12. I tell you what, I'm willing to throw in the towel here. Question 19, that's interesting. Question 19 didn't load on anything. Where did question 19 load before? It loaded on factor 2. So maybe I set my set points too low. Let's go in here and go back up and let's set the cuts at 0.3. I don't know. Question 19 therefore loads on factor 2, exactly where it loaded for the orthogonal rotation. I don't know. I'm tempted to probably go ahead. Let me explain something in this orthogonal. This oblique rotation. You end up with two matrices. One thing you end up with is your pattern matrix. And what this thing does is it contains the factor loadings much like the orthogonal rotation. In fact, if you would end up with a situation up here where all of these correlations were 0 between the components, the correlations between the components were all 0, so there was complete independence. Your pattern matrix would be, and let me show you, this is what you get. You get your pattern matrix here, okay? So it's given in your output, and it's going to be really close to your orthogonal rotation if your factors aren't correlated, which means they're independent. Your structure matrix is different, and this accounts for the lack of independence. So it looks up here and it's like, wait a minute now. This component number 1 and component number 4 are moderately correlated. So let's control for that. Let's control for the independence between between the factor. Between the components. So let's go ahead and do that. It turns out it's easy to do. So we do loadings. These things actually are matrices, so we have to do this craziness. And then we do phi. All right. So okay. Well, I'll tell you what, this would take some examination. I don't know if we can do the print psych on this or not. Let's try that. Let's do a cut. I don't know if this is going to work or not. No, it's not going to. Yeah, this is a matrix. Well, guys, you just have to crunch through this, and I don't want this this video to go on forever. So, yeah, I don't know. What you'd have to do is you just get. Let's just choose one of them. For example, question number 20. It loaded on component 3, right? And question number 7, just a random selection. It loaded on factor 1. Okay. So you know what? I would go through and probably take a look at where each of these fell and compare it to the for example, question number 1 would load on component 3. Question number 2 would load on component 2. And I would go through and just maybe do a kind of a chi-square goodness of fit test and see if the loadings were actually different. I don't see anything that jumps off the page here, but again, this would be something I'd need to get in a quiet corner and sit down and actually run through each of these and see where they where the question is loaded for the orthogonal rotation, and see how they loaded on this structure matrix. So, guys, I'm going to leave that for bigger, better stuff. But if you get into this for your master's thesis, which is a good chance you will, then that's something you ought to think about. Guys, give me 2 minutes. I need to check on something. All right, gang. Sorry about that. Okay, let's get ready to wrap this stuff up. It looks like to me I am extremely happy with this this 4-factor model. I am, if I wanted to use these factors in something, I would feel comfortable doing that. Guys, I'm assuming that we have a viable solution. I'm okay with, again, using the orthogonal rotation results if I was going to publish something. Now, the next thing I want to look at are the factor scores. And guys, let me make a something important here that I want to point out to you about creating the factor scores. These things aren't like factor loadings. Factor loadings are the things that we get back here. And notice the factor loadings and factor scores, sometimes people confuse those and they shouldn't. This just gives mostly a correlation of question 6 with component 1. And notice the big difference is for PCA loadings, factor loadings, the rows are the questions, the variables. But when we get factor scores, we're still going to have a similar look across the top. We're going to have our components, but the rows are going to be the subjects of the study. So each student, all 2,751, I think it was, will have a factor score on each of the factors. So that's a huge difference there. So guys, to get the factor scores, it's super easy to do. And what I'd like to do is not only get the scores, I'd like to be able to save them in a new data frame. So I'm going to go C bind, which is going to bind something new with something old. So I want to bind the something old, my existing data set, with the new scores from the PCA2. Now guys, remember, I've examined the oblique rotation, so I'm happy with this this PCA2 back here. I'm happy with this orthogonal rotation. I call that PCA2. So that's the reason that I'm putting it in there, okay? Now, what I can see now is I have new data. And it's a little strange because it's a huge data set. When you have this many people who have participated in the 2,571. But the cool thing now is I have a variable called RC2. So if I wanted to find the mean of RC2, I cannot do that. Okay, why not? Okay. Okay, there we go. So I just had to attach the new data set where I bound the new stuff in there. So we can see that the mean of the factor scores for RC2 are 0. And I'll just go ahead and show you something so you'll know this in the future. 0. Gee, I wonder what this one will be. You got it. And same thing for the fourth one. All right. So gang, we could use those now instead of, let's say that we were wanting to use these questions in some sort of multiple regression, but we're concerned with high correlations and multicollinearity. And secondly, imagine how large a model you would have if you have 23 predictors. Well, in this 4-component model, we retained about 50% of the variation in the underlying constructs that the 23 items actually explains. So, we could use the components. I'm sorry, the factor scores instead and the great thing about the factor scores is they're already centered. Which is always kind of cool. All right, gang, I'm done. I'm ready to go watch some college basketball. Here in, Kentucky doesn't play for another 12 hours or 11 hours, so it's going to be a while, but give me a chance to get some work done. So next thing, once you finish this video, what I would encourage you to do is to take a look at the write-up, which will be under Blackboard. It'll be under the same week, I think 10. So, guys, have a good one. Take care. Bye.